Welcome to an example in which we're finding the cosine of pi over 12 using a sum or difference formula. So the question is the cosine of pi over 12, and they want it exactly. So exactly means not a rounded decimal. You know, if you hit the buttons on your calculator, you can do it right now, hit cosine pi over 12, you'll get a decimal that goes forever. And then you'll have to round it, and then it won't be exact. So when they say exactly, they mean you can't give them a rounded decimal, because if it's rounded, it's not exact. So instead, we have to do it without that. Well, how do we do it? Well, we could use the unit circle, but the problem is pi over 12 is nowhere to be found. Let me erase what I did before. Nowhere to be found on the unit circle, right? Here's pi over 6. There's no pi over 12 anywhere. So what are we going to do? Well, the trick on this one is, first off, let's just go ahead and plug in 180, right? Pi is 180, so right there for that. So let's change to degrees. So that'll be 180 degrees over 12. And then let's just, reduce that fraction. Divide by 6, top and bottom, so that becomes 180. 18 divided by 6 is 3, so that's 30 degrees over 2. 18 on the bottom, 12 divided by 6 is 2. So that's the cosine of 15 degrees, isn't it? 15 degrees. So we could do that without a calculator pretty easily, right? That becomes 15 degrees. So cosine of 15 degrees. Now, how do we find the cosine of 15? Again, 15 degrees is not in our unit circle. We've got 30, but we don't have anything as small as 15. How are we going to do it? Can't use our calculator because we'll just get a rounded decimal, a decimal that we'll have to round. That's not exact. What do we do? Well, they gave us a big hint right here. Using a sum or difference formula, right? Using a sum or difference formula. So that means we got to think about getting 15 degrees by adding or subtracting a couple of angles. There's lots of ways you could do it. Let's go down and write. First off, let's find the cosine sum difference formula. So here's the formula sheet that I provided for you. Here's the cosine sum or difference formula. Notice it's plus minus here and then upside down minus plus there. And it's cosine cosine sine sine for the cosine formula. So let's go up and write that down. So that says the cosine of x, it's plus or minus y is cosine sine sine. And you put x here, y here, x here, y here, and you put minus plus, right? It's opposite sign. That's what they're saying when they put this upside down from that. They're saying it's the opposite sign. Okay, so what are we going to do? We got to get an x and a y that can make 15 degrees. There's a few ways we could go. Probably one of the easiest is just to take 60 degrees minus 45 degrees. That's 15, isn't it? That will do it. So cosine of 60 degrees minus 45 degrees. So x is 60, y is 45. So this will become x is 60, y is 45. Again, x is 60, y is 45. Okay, so this is going to be the cosine of 15 degrees. Now we can do it on a unit circle. Let's just go find the cosine of 60 and the sine of 60. So here's 60, cosine, sine, cosine's a half, sine's root 3 over 2. Cosine's a half plus the sine is root 3 over 2. And now let me get the cosine of 45 and the sine of 45. So 45 cosine sine, they're both root 2 over 2. So there we go. Now let's keep it going. So you just multiply straight and straight. 1 times root 2 is root 2. 2 times 2 is 4 plus. Oh, by the way, did you notice it was opposite sign here? Let me show you this. See how this is opposite? Because we had minus here, we had to subtract 60 minus 45 to get 15. Then that made it plus in the middle. That's what they're saying, opposite sign in the cosine formula. So what do we get here? Now this is root 3 times root 2 is root 6 over 2 times 2 is 4. So that's root 2 plus root 6 all over 4. There it is, the exact answer for cosine of 15 degrees. There it is. There's cosine of 15 degrees exactly with no decimal rounding. And we did it by using the cosine sum of angles, or difference of angles actually, formula.